Okay, welcome to JC Connect. In the previous class, we were discussing about the rapid sand filtration process and slow sand filtration process. In slow sand filtration process, uh, we have discussed the, the working principle of the slow sand filtration process and how exactly it is designed and what are the components of the slow sand filtration process. So the first one, that is the supernatant water. Second one, that is sand bed. Third one, that is under drainage system. And fourth one, that is filter control valves. So here you can see all the components. Okay. Normally this portion can call as the supernatant water. Supernatant water, and whichever the water will come out after filtration process, so that is nothing but the under drainage systems. For example, if the this connection is there, this also a part of the under drainage systems. And see, after filtration process, the one layer is going to form on the filter bed. One layer is going to form, so this kind of layer, it will be there, it is going to form. So this we can call it as skim deck. Okay, so it consists of many of the pathogens, and this also we can call it as a slime layer. Slime layer. Okay, and the process is downwards. The water is coming here, and after filtration, it is going like this. Okay, it is going like this. Then I already said that this process is typically for the remove pathogens. Okay, as it is a slow sand filtration process, it is typically designed for the remove of pathogens. Remember, okay. Then, so how much it should be there? The supernatant water, what we are speaking now. So it is the should be depth of 1 to 1.5 meter. So it provides a constant head of water to overcome the resistance of the filter bed or to promote the downward flow of the water through sand bed. Okay. It also provides a waiting period of some hours, that is 3 to 12 hours, for the raw water to undergo partial purification by sedimentation and oxidation and particle agglomeration. Okay, the why this supernatant water has to be maintained for about depth of 1 to 1.5 meters. So when the water is retaining above the filter bed for some time, so assume that this is the filter bed. Assume that this is the filter bed. Okay. Suppose if above this, if you are keeping, assume that this height is 1 to 1.5 meter. If you are keeping this, if you are keeping this for um, with a height of 1 to 1.5 meters, then definitely it will go under the partial purification, and we are giving more time for the sedimentation process and the oxidation and the partial agglomeration. See, uh, of course, to purify the pathogens, it is there. Remember, okay, that is the first objective. Instead of this, also, it is going to remove some portion of the cell particles. Okay, Okay, it also remove the silt up to you can say 20 to 30%. Okay, then when you keep this for about half an hour or 1 hour with the height of this, so it undergoes sedimentation process. It undergo sedimentation process and also less second one, that is oxidation. It is very important. Okay, you have two processes are there. First one, that is oxidation. Second one, reduction. Okay, so oxidation means it is the loss of electron. Of course, we will not go in detail. So reduction, it is the gain of electron. Okay, see, when you expose this for more time, normally what will happen is that it is going to expose to the atmosphere. So once it is going to atmosphere, normally the aeration process will be predominant. Aeration. Okay, once the aeration is happening, some of the pollutants that can be removed with the help of the aeration process can be removed, because we already studied the aeration process. We already studied the aeration process. With the help of aeration, definitely we are going to remove. Definitely, even we are going to remove the odor. We are going to excess IM, MN, and some of the even some of the micronutrients other than this FEMN, so that can also be removed. Okay, so even you can keep it for up to this much of depth, and if you are keeping it for some half an hour or 1 hour, so then definitely uh, we are going to remove the particles, okay, with the help of by promoting with the help of the promotion of with the help of the promotion of the help of the help of the promotion of agglomeration. See, agglomeration means assume that one particle is there. Well, these particles will come to close together. If you keep it for half an hour to 1 hour. Okay, so that is the beauty of this supernatant water. Then we already seen the depth little bit. Okay, so much depth it will be there in all those things. So most important part of this is the filter, and it has to be always maintained 1 meter. So and sand should be preferably rounded with effective diameter of 0.2 to 0.3 mm. Remember, 0.2 to 0.3 mm, and it is supported by the gravel. Okay, bottom you can see that it is 30 to 40 centimeter deep. Water percolates through a bed and gets filtered by mechanical straining, sedimentation, adsorption, oxidation, and bacterial action. So rate of filtration is zero point 0.1 to zero point 0.4 meter cube per hour per meter square. Okay, as it is a slow sand filtration, as it is a slow sand filtration. The rate of filtration is 0.1 to 0.4 meter cube per hour per meter square. Okay, to remember that. Very important thing is that effective diameter. Um, you might be knowing the coefficient of uniformity, that is Cu. Uh, it should be maintained properly. Maintained. It should be maintained properly. Then it should be supported by the gravel of 30 to 40 centimeter deep. So then the under drainage system, it is the porous of perforated pipes at the bottom of the filter. It provides an outlet to the filtered water and supports the filter medium also. Okay. Under drainage system is after filtration process. So after filtration process, you can see if the water is coming and if it is joining any of the segments, then it is nothing but under drainage systems. Okay. Then filter control valves. So normally some of the filter control valves like the meter, this will also you can call it as flow meter. Here they are going to control the flow. Okay. And also when you are controlling the flow, um, definitely we are going to maintain the constant rate of filtration. It measures the resistance of sand bed or loss of it. Okay, remember that. See, if you don't provide this control valves, then what will happen is that mm, sometimes there are chances that the sand bed is going to come out, is going to come out from the filtration system. Remember, okay, to avoid the loss of the filter as well as the loss of head, and also we discussed that loss of head, that is you have to maintain 1 to 1.5 meter. Okay, if you are not maintaining it properly, so then definitely uh, it is going to obstruct the supernatant water what we are speaking about. Supernatant water. Okay. Then filter cleaning. Uh, once that skim deck, what I told, the slime layer, it has to be cleaned frequently. Cleaned frequently. So if you don't clean it, what will happen is that I'll tell you in the figure itself. So you can see this layer. You can see this layer. This layer is going to increase. Okay. So whatever the layer is there, it is going to increase. Once this layer is going to increase, it is going to block complete whole filter. Once it is going to block, then you are unable to filter the water. Okay. This has to be removed frequently. And one major problem is that it has to be done with manually. This is one drawback in the close and filtration process. So when the bad resistance increases to such as an extent that a regular valve has to be kept fully open, filter beds needs to be cleaned. Cleaning is done by one, that is draining of the supernatant water or scraping of the top portion of the sand bed to a depth of 1 to 2 centimeter. So then whatever I told in the figure, so after this I told that this is the slime layer. Okay, This has to be cleaned with a scraping mechanism. Scraping, scraping mechanism, scraping mechanism. So after 20 to 30 scrapings, a new bed is required to be constructed. See, what will happen is that, suppose first time you will remove this, second time you will remove this, maybe after 2 to 3 months or 4 months or 5 months. It is based on the kind of water you are using it for filtration process. So once you did this scraping for about 20 to 30 times, normally whatever the filter bed it will be there, normally whatever the filter bed it will be there, this has to be cleaned or it is removed to be removed. Okay, then it has to be again processed, again it is processed. Okay, but it should not be discarded, remember. Okay, because once the sand is used for against the construction purpose, it can be reused at any times, but only it has to be cleaned at every times. Okay, then what are the advantages of this slow sand filter? So one, it is simple and construct to operate, and it is cheaper. Physical, chemical, and bacteriological quality of water is very high. Reduces the bacterial count by 99.9% and equally by 99%. So the disadvantages, it is old fashioned and outdated method of water purification. So initial cost is low and maintenance cost is much more than the rapid cell filter. Of course, we'll first go ahead with the once you study the rapid sand filtration process, then you will come to know that what are the advantages of this over the slow sand filtration process. So these filters needs a lot of space, very important. Okay, it's a old one, but nobody is using. When the bacteria are more, normally this is preferred, but we have after this a disinfection unit is there. Disinfection unit. So in this disinfection unit, we are going to remove the bacteria. So then normally it is avoided. Okay. Therefore, the slow sand filtration process is avoided because after this we are providing the disinfection unit. There definitely we are going to remove the pathogens up to 99%. Okay. Okay. Then I move on to the rapid sand filtration process. So here also, mm, if you observe this rapid sand filtration process, it has its same construction process. Okay, it is also having the sand. It is also having the under drainage system, under under drainage system, and it is also having the control wall. Okay, and extra other than this, it is having the backwashing system. It is having the backwashing system. So why this backwashing system is required, but it is not there in the slow sand filtration process. Remember, okay. See, this is like this. What will happen is that once your sand, assume that this is a sand bed, okay. So always the filtration will be there from top to the bottom. Okay, from top to the bottom, it will be in this direction. The flow of water. The flow this is the flow of water. Okay. And what will happen is that mm, once this sand bed is clogged, okay, once this sand bed is clogged means, for example, this is also sand particle, this is also sand particle. In between these particles, some particles are going to accumulate. So once these particles are going to accumulate, or air bubbles are going to create, so then the head is going to develop on the above the filter bed. Okay, above the filtered air. So when the filtration is not happening, so then what will happen? It will start overflowing. Okay, once the head of water is developing, and once it is overflowing, okay, then you assume that the filter bed is clogged. The filter bed is clogged. Then how to remove this? If you want to remove, you have to remove it. Then what you have to do that? We have to uh, push the water from the bottom. Okay, you have to push the water from the bottom. Once you push the water from the bottom, so then it will be disturbed. Whatever it is there, it will be, the bed is going to disturb. So once the bed is going to disturb and it is lifted, okay, it is lifted and it will be taken away in other uh, channel. There, thereby doing that backwashing system, we are going to remove the clogged particle from the sand bed. So that is the advantage of this rapid sand filtration process. Here you can, in this figure you can see these are the bed, this is gravel and this is sand. This is the water level. You can see that here is the water level, and so this portion, whatever it is there, it is the backwashing purpose. We are using this water, and one tank will be there. Okay, one tank will be provided uh, for only backwashing purpose. Okay, the water will move from this direction to this direction. Okay, this is one major advantages in this rapid sand filtration process. Rapid sand filtration process. As the name indicate, the filtration process is higher. Filtration process is more. Filtration process is more. Okay. Normally here, the head what we are speaking about in the previous case, that is slow sand filtration process, their head is very less. It is zero point 0.5 meter. Okay, almost it is the rapid sand filtration process is almost 4 to 5 times more than the slow sand filtration process. Okay, then cleaning and maintenance. When the loss of head reaches to 7 to 8 feet, it has to be cleaned, and it is cleaned by backwashing. I already told it. So exactly the backwashing is going to help. So backwashing is done by reversing the flow of water through the sand bed. Okay. So I said that this is the flow of water, filtration, filtration. Okay. And what will do when you are doing the backwashing? This is what the direction. Okay. So reversing the flow. It will dislodges the impurities and clean up the sand bed. Okay. Sometimes the compressed air can also be used in backwashing. Compressed air means what? I told this is also sand, this is also sand. Here the impurities will be there. Suppose once you blow the air, once you blow the air, okay, so definitely um, we are going to remove this impurity that is present in um, this sand bed. Okay, of course, the frequent cleaning is required for about 1 week. Within 1 week, uh, we'll go ahead with backwashing. But in slow sand filtration process, it will be 2 to 3 months. Remember, 2 to 3 months once we will remove that skim deck or the slime layer. So what are the advantages? So the advantages: deal with raw water directly, occupies less place, filtration is rapid, washing of the filter is easy because it is mechanical. Remember, okay. In slow sand filter, normally it is manual. It is manual and more flexibility in operation. So relatively high skill operation, costlier, and removes bacteria by 90 to 99 percentage. Okay. Then the differences between the slow sand filtration process and the rapid sand filtration process. If you are talking about slow sand filtration process, so large area is required. It requires small area. Okay, rapid sand. Rate of filtration you can see here it is zero point 0.1 to zero point 0.4. Here it is 5 to 15. Just imagine almost you can say um, 50 times more. So almost 50 times more. Then the effective size of the sand, okay, it should be zero point 0.2 to zero point 0.3 mm, but here it is 0.4 to 0.7 mm. Okay. Then here the size is less. Remember, that is why it is slow. Suppose if you are maintaining same size here, suppose if you are maintaining the same size here, it won't work. Okay, the filtration will not be faster. Filtration will not be faster. Not be fast. Suppose if you maintain the same 0.2 to zero point 0.3 mm in case of rapid sand filter, it won't be fast. Okay. Then preliminary treatment is required or not. Okay. Uh, See what will happen is that so we have the systematic process called um, aeration. Then it will be screening. So then we have sedimentation, coagulation. So sometimes there is sedimentation come coagulation. So then it will be a filtration. Okay, when the water is coming to a filtration process, before that any pre-treatment is required or not? Before this, okay, what are you saying that? Suppose the plain sedimentation is this sedimentation process is required. You cannot directly supply the raw water to the filtration process. Remember, you cannot supply directly the raw water to a filtration process. So after the plain sedimentation only, you have to supply the water to a filtration process. And rapid sand filtration process, it requires coagulation as so these two processes are required. So one process and two processes are required when you are sending to a RSF. Okay. Normally, uh, rapid sand filtration is designated as RSF, and the slow sand filtration is designated as SSF. Okay. Operation is less skilled. Okay, high skilled um, operational person is required. Then loss of head is 4 feet. Here it is 6 to 8 feet. So the removal of turbidity, it is good. It is also good. So removal of color, it is fair. It is good. So removal of bacteria, it is 99 point, and here it is 98 to so very less effective. Okay, comparing to that. So these are the differences between the slow sedimentation process and rapid sand filtration process. Okay, with this we'll wind up the class. Have any doubts? You can ask.